Hey hello everyone, Ranjit this side. So in the previous video, we tried to investigate if a given time series is stationary or not with the help of couple of tests like ADF and KPSS. In this video, we will try to understand how we can make a non-stationary time series into a stationary one by using one or more than one type of transformations. Now, there are a couple of ways of making a time series stationary, but sometimes it works and sometimes it doesn't work based on the data that we have been provided. Now, one of the option is doing the deflation part. So we will work on a consumer price index, which is like a trending data, and then we will try to deflate the inflation based on that data. That's the first way. Second way, we will be applying the natural logarithm. So as you know that, with the help of log, we can reduce the data into a linear data. Last but not the least, it's a differencing. So we'll be taking the difference between the current observation and a lagged value like the previous value, and then we'll try to differentiate it. Now for this video, we will be using the monthly gold price, which will be dated from, let's say, from 2000 to 2010. Why we have taken this data is because over that period of time, the price of the gold shown a consistent increase in the trend, and this basically shows that that the series is definitely not a stationary data. Now when we come on to the coding part, we will be using a pandas library, numpy, Nasdaq. Again, you need to create an account and install this Nasdaq library. Then we have CPI. So sometimes this CPI will not work if you have installed it, so make sure that you restart the kernel and then it will work. Then we have imported date time. Again, the API key, make sure that you get your own API key. And then we have matplotlib. But why? Because we will try to visualize the data. Apart from that, we'll be using ACF and PACF because we would like to see if the data has become stationary or not from the raw data that we'll be fetching. Right, so the first step will be to get the data from, okay, let me run this. This is taking time because of the CPI part, because CPI has a huge data in that. CPI is basically a consumer price index data from US market. Right, so it took 23 seconds. It's too much. Okay, now we will get the data from Nasdaq website, which we'll be using the API like I mentioned earlier. So we'll be using the prices of gold, and then we will, of course, we'll give a value and the price as the columns, and then we will take data from 2000 to 2010. Like you mentioned, there is a trend in that data, and then we will resample it into a monthly data, right? So let me just run this and I will show you the data. On a couple of days back, I received a mail stating that the Nasdaq API is about to expire. But anyways, so this is the data that we have. It starts from 2000 and then we have converted into a monthly data, right? So this is the price, and then as you could see, we have made sure. Okay, so the date is an index part over here, so we don't need to forcefully make the date as index. Now, the first part, like I mentioned, we'll be deflating the gold price. We'll plot the result. So for that, we need a deflate date, so that till this date, we'll be deflating the data. Now, what we need to make sure that this deflate date could be of another point in time, but make sure that it is at the same point for the entire series. So make sure that this date is within, or let's say yeah, within the range of the data that we have, and then we have to take the entire series. So this date should be the last date of the entire data, right? So now what we are doing from this data frame, we are making sure that the date time is the index part. So now let me just run this deflation date, and then we have index data. Now let's try to apply the inflation part, or let's say deflate the data, right? So for that, what we have done, we have used the CPI library to make this data, or create a new column called price underscore deflated. So lemdax, it's a customized function which basically takes the price and the index and then deflates it on the base of this date. on axis 1, right? So yeah, now let's try to make the plot. So this is how the data looks like. So the blue one was the actual price that we had, inflation price till the date of, let's say, what we mentioned over here, till 31st December 2010. We try to deflate it, and then you can see the yellow line is the deflated price. Basically, we try to remove as much as inflation as possible. Apply the log. So for that, what we have the 12 months over the data. So the columns that we'll be using is the price log, and then we have rolling mean, and then the rolling standard. So for the price, or let's say normal logarithm, that we'll be applying on the deflated price, and then we have mean of that data, which is a window. So the window dot mean, what it basically does, it will roll on to the next 12 months, right? Or let's say next month on. It basically shifts one month ahead, so it keeps on rolling to the next month, right? And then we have 12 months, and the same goes for the standard deviation, right? So now if we run this, so again we have price log, rolling mean log, and standard deviation log. Now if you see the prices over here, so this was the actual price or deflated price earlier we had. Now after the log part, we have price log as this one, and rolling mean, and the standard rolling mean. Now what it basically mentions that, we try to make the data stationary as much as possible, but by just viewing the graph will not help us. So what we need to do, we will do the test part, which we basically did in the last video as well. So for that, we'll be testing the autocorrelations. So within that, we have two, PACF and PACF. The significance level that we are mentioning is 5%, right? So 5% basically means that, 5% of the differences, or let's say, the deviation is okay, right? And then this is a function, and we will be creating the plot for that. Now if you see over here, it's basically shows that the data is not stationary, because we have some ups over here, right? So we need to implement some more data cleaning, let's say. So for that, what we'll be doing, so again we have three columns over here that we have selected. Now like I mentioned, the last step that we had was to do the differences. So again, for the differences part, we will be shifting that column, or let's say the one row. So we'll be differentiating the current row with the with the previous row. For that, we did the difference over here of 1, and then we have price log difference, and then we have rolling mean log difference, right? So rolling mean, again, we did the rolling mean of the same price log difference, right? Again, so sorry, I need to run this and run this. So we have price log, rolling mean, and then again we have standard deviation log, and then the selected columns. Now what we'll be doing, we'll be creating a plot for this. So let's do that. Now if you see, the data is more of a stationary, right? It do not shows any kind of trend in the data. And then let's also check the autocorrelation, because this is what more important is. So even though you might see couple of like highs over here, right? We have over 11, we have over, I think it is what, I think this is 22, and then we have somewhere around 38, 39, I think, right? So even though this is showing some deviations, but it's okay, because I think this is more of a 5%, and we did mention that, the significance level is 5% over here. I think this has become more of a stationary data now, right? And then now we can use this data for, let's say, any model. So yeah, that's all. Thank you so much. Have a great day. Take care.